Now we continue with new subtopic, which is subtopic number 5, that flow with heat transfer. And there's heat transfer but negligible friction. So this one we call Rayleigh flow. So in many compressible flow problems, they encounter in practice involve chemical reaction such as combustion, nuclear reaction, evaporation, condensation, and heat gain, heat loss through the duct wall. So if we consider all of this, the problem will be very difficult to analyze. Before we want to make assumption. So for Rayleigh flow, essential feature of such complex flow can be captured by a simple analysis. Analysis method where generation and absorption is modeled as heat transfer through the wall at the same rate. But this is still too complicated for introductory treatment since flow may involve friction, geometry changes, 3D effects. So we use Rayleigh flow as a simplified model. Okay, what is Rayleigh flow? Rayleigh flow is steady one-dimensional flow of an ideal gas with constant specific heat through a constant area duct. Okay, this is a constant area duct with heat transfer but with negligible friction. So we consider only heat transfer but no friction. So this is the formula that some of them we are familiar, some are not, but try to be familiar with this formula: continuity equation, momentum equation, energy equation. It's actually heat Q, entropy change, and equation of state. So this equation is for Rayleigh flow. So we use this formula to get the state at location 2. So after we use the formulas, we can know that this is quite tricky, where there are 3 sections where the tricky part is at the temperature. If you look at here, when there is heating, what will happen when we heat? The temperature, we assume that it will increase, but for subsonic flow, some of them can increase but some of them can decrease. But for supersonic, when heating happen in the duct, the temperature will increase. So if you look at here, this is for supersonic. So supersonic is straightforward, where when during heating the temperature increase, but during cooling the temperature decrease, like a normal behavior. But for subsonic, which is speed lower than sonic or supersonic, there are 2 sections.